Okay, like I said, trapezoids and kites today. This gets fairly complicated, but we can work it out. You're a bright bunch of individuals. Here is a trapezoid. What is it? Wilma.
Quadrilateral with one pair of angles.
One pair, and only one pair? That's it. You can't have two pair. Are you sure? Okay. Let's see. Shazam. Exactly one pair of parallel sides. There are actually two ways to define a trapezoid depending on what source material you're using. We're going to use this information that it has exactly one pair. You could say that it has at least one pair, but then that causes a whole bunch of problems that we don't want to really get into, but some people would define it that way. Once it has two pairs of parallel sides, it's no longer a trapezoid because it becomes, nope, a parallelogram, correct. So, is a trapezoid a parallelogram?
No.
No. Is a parallelogram a trapezoid?
No.
No. Good. They don't belong together. They don't play well. Those two parallel sides, not the top and bottom, because we will take that shape and flip it around. The two parallel sides are called bases. What do you think the other two sides are called? Legs. Well done.
It is a genius.
This is a mistake on my part. I did not intend for these to be marked congruent. They're just two angles. Those angles are called the base angles. Okay. The base angles are a pair. Those two are the base angles because they're attached to the same base. Okay, so PA is a base, therefore angle P and angle A are base angles. And then of course we have another pair of base angles up on top, which I was awake enough to mark those as not being congruent to each other. They don't necessarily have to be congruent. So two pairs of base angles. Consecutive angles, consecutive non-base angles are supplementary. Well, that makes sense because what kind of angles are those non-base angles?
Consecutive interior.
Consecutive interior angles, correct. And there's nothing else exciting about trapezoid. Okay, that's it. One pair of parallel sides by definition, and consecutive non-base angles are congruent.
Oh, I get the joke.
Good. Good. Anybody not get the joke?
I really did.
You could reenact it.
Two guys walk into a bar, the third one ducks.
Oh,
You still don't get it, do you?
I know, I get it now.
Explain it to me then.
It's like they walk into it's like the bar over their head, like a metal pole. kind of
Like a
thing,
metal
and
pole,
then-
right? Not a drinking establishment.
Yeah.
Right. You want to try another one?
Nah, I'm good.
You sure? So if I say to you, a horse walks into a bar and the bartender says, "Why the long face?"
Oh.
I
don't get that.
I had to get, but I
Because
got
a horse has a long face.
You guys never heard these.
What do you
Yeah,
want?
no,
Like
that's
that
right.
way and it's just
You guys have never heard of these?
Are you really trying to sort out the horse and long face joke?
I don't get it. A horse doesn't have a long face.
Yeah, it does.
Yeah.
It's like this.
All right, let's try this one. A piece of string walks into a bar and climbs up on the bar stool and says, "Give me a drink." The bartender says, "We don't serve string here." You're like, "Come on, no, we don't serve string." So he leaves and he's sitting out in front. This woman walks by and he says, "Excuse me, miss, do you have a comb?" She says, "Sure." He says, "Could you comb out my ends, please?" So she picks up the string and she combs out one end and she combs out the other end. She goes, "Is that all you need?" He said, "Well, can you tie me in a knot?" He picks up the string, ties the knot. She says, "You need anything else?" He says, "No, I'm good." Heads back in the bar, climbs up on the stool. Says, "Give me a drink." Bartender says, "Wait a second. Weren't you that piece of string that was in here before?" And he says, "No, I'm afraid not."
Oh my god.
Afraid not.
I had it.
I did not see that coming at all.
Okay, so now we want to prove that quadrilateral is a trapezoid. Similar to the problems with 17 and 18 we just went over in homework. You need to do two things. You need to prove that it has one pair of parallel sides, but you also have to prove that the other side isn't parallel. Okay, so we got to get it away from the parallelogram family. Just like if you wanted to prove it was a parallelogram, you'd have to show that both pairs of opposite sides are parallel. In this case, you show that one pair is parallel and that the other pair isn't. You still got to do force slope calculation. Excuse me. Okay, not the most exciting figure in the world.
Wait, can you go back?
Yes. Are you with that?
What's the formula to find the area of trapezoid?
We're not there yet. I could tell you, but your brain would explode. We good? All right, isosceles trapezoid. So, what do you figure an isosceles or an isosceles trapezoid would be?
That the two legs would be congruent.
Beautiful. Just like an isosceles triangle, an isosceles trapezoid is a trapezoid with congruent legs. Well, that was quick. Why did that happen? There we go. Is an isosceles trapezoid a trapezoid?
Yeah.
Yes. Is a trapezoid an isosceles trapezoid?
No.
No.
All the time.
Before we move on, what other things do you think we get out of it now that the legs are congruent?
Angle G and angle O are congruent.
And?
And angle F and angle R are congruent.
Good. The base angles now all of a sudden become congruent. Anything else?
F and G are supplementing what they were before, and now F and O are supplementary. Angle, F and O.
Oh, nice, yeah. Opposite angles are supplementary. All right, anything else? How about the diagonals?
Oh,
They're what?
congruent.
Congruent?
Yeah.
What about perpendicular?
No.
No?
No.
Can they be?
Yeah.
Yeah.
Can be, but don't have to be.
Right.
Okay. Sorry, you got a cramp?
Kind of.
Okay.
No.
Just want to take a little walk around your desk there for a second, stretch your legs.
Was to the left of my backpack. I wanted it on the right of my backpack. I wanted to straight on my backpack.
Okay. Sometimes I regret asking questions.
The set of words you used was fantastic.
Okay, so a trapezoid has a pair of congruent base angles if and only if it's isosceles. Remember, the if and only if statement means it's reversible. So if it's isosceles, the base angles are congruent. If the base angles in a trapezoid are congruent, then it's isosceles, and we can switch back and forth between the two because it's an if and only if. The diagonals are congruent also. So now you have to be careful. If you're doing a coordinate geometry proof and you calculate the length of the two diagonals and they're congruent, it could be, well, let me ask you that. Let me ask you the following question. You do that and you find that the diagonals are congruent. What possible shapes could it be? A rectangle? A square?
Any trapezoid.
A parallelogram. It's a round body.
What kind of trapezoid?
Isosceles.
Isosceles, not regular. Okay, yeah. All right. Then we have this new thing called a midsegment. So if I take the midpoint of the legs of any trapezoid and I connect them, I get something called a midsegment. I don't have a picture of it, but it's the segment that connects the midpoint of the midpoints of the two legs. The length of that bad boy is the average of the two bases. Take the length of the two bases, add them up, divide by 2, you'll find the length of the midsegment. Oh, I also forgot to mention it's parallel to the bases. I got to picture one in a second in the first example, so okay, we'll get there. Okay, good?
No.
How about now?
No.
What about now?
No.
How about yet?
No.
Got it now? Where, you're writing every word, aren't you? Are you changing colors too to match? Do you have the blue stripe in there and the yellow dot?
No.
Okay, just checking.
That's
Are you using the same font?
No.
Okay.
I should.
it's like
Trapezoid or isosceles trapezoid? Trapezoid, right, because these are different lengths. So R and M are the midpoints. In this case, I gave you the length of that midsegment. And so I'd like to find out the length of TS. Somebody had a question over here?
oh, I thought I knew, but I don't anymore.
You don't anymore, okay. Well, how would you find it? Let's call this X. What equation would you set up? Grace?
I did 26 plus x, and then parentheses, and then times divided by 2, and then equals 38.5.
Perfect. $38.5 times 2? 79? 77?
Yeah.
77.
So that's what
No problems? Okay, you have to be sure that these are midpoints. How do I know they're midpoints? Because those tick marks show me that they are midpoints. And it's a little hard to see, but there are arrowheads in there to verify that it is in fact a trapezoid. Since it doesn't say in the problem that it's a trapezoid, you need to have some information in there. Yes, sir?
That's not actually a question, but so the difference between 26 and 38.5 is 12.5. This difference between 51 through 38.5 is 12.5. So would that just keep on going down? Okay.
Nature of an average. Okay, we good? Yeah. Okay, good. 51. All right, kites. Our last shapes. I'm sad. There's a kite. What's a kite? Were you talking? Was that you or her? What? Oh yeah, I like how you pointed at each other. That's funny. Wilma,
It's a quadrilateral.
didn't you give us trapezoid also? Wow. You're like a shell answer woman today. Go ahead.
It's a quadrilateral.
Good start.
With no pairs of parallel sides.
I like they spelled out kite.
You got that, huh? Yeah, yeah. No pairs of parallel sides? Okay.
And it's
Oh wait, there's more?
Yes.
Okay.
And two non-opposite sides are.
Two non-opposite sides are congruent. That's beautiful. Question? Is there another way that we can say non-opposite? Wilma?
I don't know.
What'd she say?
You don't understand.
She did? What?
Well, you could say adjacent, but then you could do KI and IT, and those aren't congruent. So like lengths that share the same vertex.
That's still missing.
Oh wait, no, that's still the same definition.
Well, I don't think it would
I think
matter
I would
if
have
KI
it.
and IT were congruent.
What,
It would just
could
look
you say they're
different.
perpendicular?
What are perpendicular?
Well, like
I don't like
there-
pronouns.
Okay, there's two sides that are perpendicular to. Perpendicular, like. I don't know how to describe it. But they're perpendicular.
What's they?
KI and KE.
Are perpendicular?
Yeah.
Do they have to be? So you're saying that's a right angle?
I think so.
Is that a right angle?
Oh darn.
Is that a right angle? Is that a right angle?
Okay, never mind
Okay.
then.
Whoops, wrong mode. Two pairs of consecutive sides, congruent, but not the opposite sides. We have to include the opposite sides because if we just say consecutive congruent sides, then that would also qualify a parallelogram and a rhombus and a rectangle and all those other fun things. What else appear? Yes, sir?
Can it also be a parallelogram?
Great question. Can it be a parallelogram?
No.
It can be, but would it be considered a kite?
It can be.
Well, okay, never mind. But can a kite be a parallelogram?
Excellent question. Can a kite be a parallelogram?
No.
Why not?
Square.
Opposite sides are not congruent. And in a parallelogram, the opposite sides have to be congruent. So like trapezoids, kites do not play well with the other guys. Because they're not parallelograms, they can't be rhombi, they can't be squares, they can't be rectangles. They're off doing their own thing. What else appears to be true about this bad boy? Wilma.
The diagonals are perpendicular.
Diagonals are perpendicular, very good. Anything else? By the way, just to get some terminology under control here so we can all refer to things in the same way. These two vertices, which are the vertices between the congruent sides, are called ends. E-N-D-S. Ends. Okay, so as Wilma said, they are in fact perpendicular. Anything else? Nick?
The diagonals are perpendicular. Is that what she just said? No. I realized once I said it that I heard perpendicular.
I understand. And there's a little box there too.
Doesn't look like a box. I got confused.
Oh.
Those are fighting words.
How about the angles? Angle K congruent to angle T? Yeah? No.
No.
No? How about angle I congruent to angle E?
Yes.
Oh, okay, yeah, sure. So how would you say that?
Non-end angles are congruent.
Love it. Non-end angles are congruent. So let's go through some of the properties of the other quadrilaterals we've covered and see if they also apply to this bad boy. We already talked about the diagonals being perpendicular. Do the diagonals bisect each other?
No.
No. But
No, they have to bisect each other.
Really?
Oh, okay, never mind then.
Senor?
The diagonal going from end to end bisects
Oh.
the diagonal going from the non-ends.
Well said. This guy is congruent to this guy. But that one is not congruent to that one.
Do you have a name for like I and
Do I have a name for what?
I and
The non-end diagonal?
Wait,
Nathan? What's the matter? Wait, hold on. Clarification, what?
how do you write that?
The as opposed to writing it on the bathroom wall or scratching into your dad's car or
Like how
or on your iPad.
Sure. Well,
The diagonal connecting the ends bisects the non-end diagonal. Wilma?
isn't angle IKT congruent to angle TKE?
This angle congruent to which one?
The one next to it.
This one? I like it. However, before we make a statement about that, Wilma, do you think that this angle is congruent to this angle?
No.
No. So how do we state this? Oh,
The end angles are, well, they're bisected by.
good. Yep. The end angles are bisected by the diagonals. Nathan?
Can both ends, are they complementary?
Nope.
Could they be?
Sure. Then we've got some triangles here. I'm gonna get rid of all this mess here. Just so we can start over here. This triangle is congruent to that triangle. This triangle is congruent to that triangle. What kind of triangles are these?
Right.
Right. What kind of triangles are these? The big ones?
Isosceles.
Isosceles, correct, and they share a base. Notice that this triangle is congruent to this triangle because the end diagonal cuts it into two equal triangles. So you got a whole bunch of stuff going on in the kite. It's rather confusing. Okay, so let's make sure we got everything. Diagonals are perpendicular. We got that, right? Exactly one pair of opposite angles are congruent. Got that. One diagonal is a perpendicular bisector of the other diagonal. Got that. And we got a picture down there. Great. And then we got a problem. Or an example, I should say. What is the perimeter of RATS? What's the perimeter?
Not length, but the,
Length.
I know what it is, I don't want to
Okay.
like in words.
Okay. A whole bunch of sarcastic comments I could make, but I'm just going to let them go. Yes?
Oh, wait. Oh, never mind.
Okay. For discussion purposes, let's label this middle letter as X, or that middle point as X. Just so when we start explaining the problem, oh boy, the bell's going to ring. Okay, let's work quickly. I'm going to go through this and not wait for you. How do I find Rx?
Right there, it's 12.
It's 12 because the end diagonal bisects, so that's 12 also. How do I find RA? Pythagorean theorem, 12 squared plus 12 squared equals RA squared. And RA is the same length of AT, that takes care of that. Then how do I find RS? 20 squared plus 12 squared equals that, and then that's equal, add all those up, we're good to go. Great, let's move on. Sorry, going through this quickly here. Answer, great, we don't care. Well, there's a keyboard for some reason that popped up. Okay, you can go away now. Keyboard bad. Okay. What do you know about all four angles in a kite?
They equal 360.
They equal 360, and that, okay, here's the answer. U and S are congruent, so 360 minus 62 minus 132 divided by 2 will tell you how big each of those angles are. And we're done. Yeah! 2 days on this material because there's a lot of information to digest about trapezoids and kites. Okay, so we'll do the homework tonight, day 8. We'll go over that homework tomorrow and then progress on to day 9 without a lesson, so more of the same stuff.
Is it on?
That's a great question. I don't know. I'll check in 2 seconds. Okay.